So if we have tangent from the same external point to the circle, then they are equally inclined to the line joining the center. Now, if you have two tangents from the same external point, and if the external point is joined to the center, then both the tangent will be equally inclined to the line joining the center. That means PA tangent PA is making angle 1 with the line joining the center, tangent PB is making angle 2 with the line joining the center, and angle 1 and angle 2 will be equal. If we have two tangents from the same external point, then they will be equally inclined. That means angle 1 and angle 2 will be equal. Okay, let's take the next one. Now also we have two tangent from the same external point, and tangent from the same external point subtends equal angle at the center. So the tangent if PA will subtend an angle say 1, and tangent PB is subtending say angle 2, we can take angle 1 and 2 equal. That is tangent from same external point to the circle R equally R tangent from the same external point to the circle subtends equal angle at the center. Tangents from same external point to the circle subtends equal angle at the center. So if PA and PB are tangents from same point P, then what you can take, then say PA is subtending angle 1 at the center, PB is subtending angle 2 at the center, we can take angle 1 and 2 equal. Okay, write it, and if you're done, you can just raise a hand. Okay, so I think it's done. One more theorem we're going to say. Okay, say PQ is tangent at A And at A we have a chord. So AB is a chord at A, and the chord is making an angle BAQ on the right segment, on this segment, on this small minor segment, it is making, on the minor segment, it is making this angle with the chord. And the same chord is making this angle at the circumference in the opposite segment, in the major segment. The same chord is making this angle in the major segment. We can take these two angles equal, and they are known as angle in the alternate segment. Okay. Then angle BAQ will be equal to angle C. So for angle in the alternate segment, there will be chord at a point of contact. At a point of contact A, we have a chord, and the chord is making angle BAQ on the right side, on the right segment, or in the right segment. This is the right segment or minor segment. And the same chord is subtending angle B or angle C at the major segment. This is the major segment. This part is the major segment. At the major segment, it is subtending angle C. And both this angle, we can take it equal by angle in the alternate segment theorem. So angle in the alternate segments are, there will be a chord, there will be a tangent, there will be a chord at the point of contact, and whatever the chord make, or chord will subtend an angle in one segment with the tangent. So the chord is making an angle with the tangent in one segment, and the chord is subtending an angle in the opposite segment at the circumference. We can take both these two angles equal by angle in the alternate segment theorem. Angles, make it plural. Angles in the alternate segments are equal. Okay, fine. If you're done, you can raise a hand. Okay, fine. So once again, I'm telling, and in the angle in the alternate segment, there will be a chord, or there will be a tangent, and there will be a chord at the point of contact, and the chord will make an angle with the tangent in one segment. It is making this angle in this segment, that is minor segment. And the same chord is subtending angle C at the major segment. This is the major segment. The bigger part, the chord divide, any chord divides the circle into two parts, bigger part and smaller parts. Smaller part is a minor segment, bigger part is a major segment. So the chord will subtend an angle with the tangent in one segment, and the chord will subtend an angle in the opposite segment at the circumference. And these two angles are known as angle in the alternate segment, and they will be equal. They will be equal. Okay, now let's see. Exercise 10.2, question number 4. Prove the tangent drawn at the end of a diameter are parallel. So if you draw a tangent at the end of the diameter of a circular parallel. tangent drawn at the end of the diameter are parallel. Prove that the tangent drawn at the end of the diameter are parallel. So there is a circle with center say O, and say PQ is a diameter, POQ is a diameter, and at the end of the diameter we have tangents. Say AB is a tangent at P, and CD is a tangent at CD is a tangent at Q. So AB and CD are two tangents at the end of the diameter, that is P and Q, and you have to show that the tangents are parallel. The tangents are parallel. Okay, so given is what? A circle with center O. Whenever there is a circle, you have to mention the circle and the center. Center O. Okay. Can you hear me? Just raise your hand once. Okay, fine. A circle with center O. Then what? There is a diameter. The diameter is POQ. POQ is a diameter. Then AB and CD are tangent at P and Q. AB is a tangent at P. CD is tangent at AB is a tangent at P. CD is a tangent at Q. To prove what? AB parallel CD. Okay, good. Okay, first thing. This POQ is a diameter and AB is a tangent. So that means OP is the radius at P, and we have a tangent at P. So this angle will be 90. Angle 1 will be 90. Again, same way, OQ is a radius and CD is a tangent. So angle 2 also will be 90. So first we know that these two angles will be 90. So we'll write that. Angle 1 equal to 90. Angle 2 equal to 90. Why? Tangent is perpendicular to radius. Tangent perpendicular to radius or radius. Okay, mark it 1 and 2. Okay, now we have to show this AB and CD parallel. To show AB and CD parallel, this 1 and 2 are co-interior angles. 1 and 2 are co-interior angles. And if you can show angle 1 and 2 90, angle 1 plus angle 2 is 180, or if you can show the sum of the co-interior angle equal to 180, then the lines will be parallel. Then the lines will be parallel. Lines AB and CD will be parallel. Okay, now we know angle 1 is 90, angle 2 is 90. So now let's take the sum of these two co-interior angle. Angle 1 plus angle 2 will be what? 90 plus 90. Adding 1 and 2. If you add equation number 1 and 2, what will get? Angle 1 plus 2 will be equal to 90 plus 90. So what you're going to get, angle 1 plus angle 2 is 180. Angle 1, we have taken angle 1 is 90, y tangent is perpendicular to radius, we marked it 1. Angle 2 is 90. Again, we marked it 2 because tangent is perpendicular to radius. Now, if you add these two equations together, we'll add the left hand side together. So on the left hand side, we'll get a 1 plus 2, and then we'll add the right hand side together. On the right hand side, we'll get what? 90 plus 90. So angle 1 plus 2 equal to 180. So what are you getting? Angle 1 plus angle 2, we are getting equal to 180. Now, we are getting angle 1 plus angle 2, 180. That means we are getting sum of the co-interior angles. The interior angles on the same side. Both the angles are in between the lines and they're on the left side. Both are on the left side. They're on the same side. And we got the sum equal to 180. So we can take, therefore, we can take AB parallel CD. Why? Since sum of the co-interior angle equal to 180. Since sum of the co-interior angles equal to 180. And that is your answer proof, so hence proof. Okay, if you're done, you can just raise a hand. Okay, fine. Okay, let's do question number 6. 5 we'll do it next time because that time is quite less. Let's do question number 6. The length of a tangent from the point A to the at a distance 5 from the center of a circle is 4. Find the radius. Question number 6. The length of a tangent from a point A to the circle from a point A at a distance of 5 meters from the center. The length of a tangent from a point A at a distance of 5 cm from the center of the circle is 4. So length of the tangent is 4. Find the radius. You have to find the radius. So we are taking AB is a tangent at B, and it is told in the question the length of the tangent from the point A to the circle is 4, and the point A is at a distance of 5 from the center O. That is given to us. So given is what? A circle with center O. Then AB is a tangent at B. AO is given 5. AB is given 4. To find what the radius. and here the radius is OB, so OB question mark. To find OB. Okay, to find OB. Okay, how to find OB? We know what tangent and radius are perpendicular. We know this angle is 90. So first we can mark it in the figure also. Mark it in the figure. Angle B is 90. So first we can take angle B equal to 90 y tangent perpendicular to radius at the point of contact. So if angle B is 90, triangle AOB is a right angle triangle. So in right triangle, what you can do, we can use Pythagoras theorem. So what is Pythagoras theorem? Opposite to 90 is hypotenuse. So AO square, we can take it equal to AB square. What is Pythagoras theorem? Hypotenuse square equal to sum of the square of the other two sides. Hypotenuse is AO and other two sides are AB and OB. Now put the values. AO is how much? 5. AB is how much? 4. OB is OB. Now solve it. 5 square is how much? 25 equal to 4 square 16 plus OB. Now we're going to find OB. So leave OB on the same side. And the 16 take it to the other side. So 25 minus 16. 16, if you take it to the other side, it becomes minus. First write what is on the other side. We have 25, write it. 25 minus 16 is 9. Then again find OB. How to find OB? We'll take root on the other side. And root of 9 is how much? 3. Therefore, OB equal to 3 cm. There was unit, so put the unit. So OB will be equal to, at the end, we can write OB equal to 3 cm.